All right, welcome everyone to another OCP Tap call. This is call number 124. Today we have Jack Keating from STAC. So Jack has over 30 years of experience in development of business management of financial technology. As a CEO of STAC, Jack leads the expansion of the STAC community and the value that STAC delivers to the community. Prior to STAC, Jack was a head of FX technology at London Stock Exchange Group, and the global head, global head of the trading technology at Refinitiv, and the global head of wealth management technology at Refinitiv, and the head of Elektron real-time platform at Thomson Reuters. Earlier in his career, Jack was second in command at STAC, helping build it from the ground up in its first 7 years. Jack has a Bachelor of Science in Computer Science from the University of Illinois in Urbana-Champaign, and Masters in Financial Markets and Trading from Illinois Institute of Technology, Stuart School of Business. So today's presentation will be mainly about learning about STAC. And with no further ado, Jack, the floor is yours.
Great, thanks so much. So I thought I would give an overview of the STAC Benchmark Council, which is the main aspect of what we do in STAC. Let me see if I can get my advancing here. There we go. So the STAC mission, what we're here for is we're really about improving the efficiency and effectiveness of technology discovery in the finance industry. From working with many clients throughout our history, we've found that, of course, financial institutions need sophisticated technology. They build this, they buy it, they live and die by it. And that technology discovery and evaluation is both slow and expensive for them. So figuring out who they want to look at, how they're going to look at it, and finding and the time and cost available to do that is a challenge. And overall, this hurts both the buyers and the sellers of that technology solutions and slows down the advances that people need to make in the industry. So we established the STAC Benchmark Council in 2007 to help in this process. So the council consists of financial firms, which we call our end users, and technology providers, which are the tech vendors. And what the council does is it establishes standard technology benchmarks on financial workloads, and it also discusses important technologies and research agendas based on the priorities of end users that we talk to. We do this through a series of working groups and special interest groups that go well beyond the benchmarks that we developed. And the benchmarks that the council uses are defined by collaboration of STAC and through the end users and the vendors. And we'll go into some details in terms of how the process works. So who participates in the council? We have about 500 end user members. So these are financial organizations and business application vendors that are in the process. These consist of hedge funds, proprietary trading, exchanges, brokerages, clearing firms, asset managers, digital assets, banks, insurance, trading platforms like OMSs, EMSs, ATSs, analytics providers, as well as insurance and wealth and regulators. Now, we also have about 75 technology providers that participate in the council. If you look through many of the logos that are on here, you'll see big server vendors, you'll see chips, including CPUs, FPGAs, GPUs, inferencing chips. You'll see network providers from NIC switches and RF connectivity, storage, databases, memory, cooling, operating systems, public and private cloud service providers, data centers, time synchronization, data capture, trading UIs, professional services. There's a lot of people that participate in the council for a lot of different reasons. Now, the STAC Council, we'll go into a little bit about how our council works. So now that you know a little bit about those participants, the end users and the tech vendors, we get everybody together as part of that council and community process. And we establish different working groups and special interest groups through the council to talk about challenges that they have in terms of strategic workloads that are important to their financial institutions and important to their capital markets trading operations. So we talk about those, we get everyone together. It's often a little bit of a challenge getting everybody to, openly communicate in the process as we start out, because this is an industry where people are quite secretive about what they do. As we work through the process, everyone gets a bit more comfortable, shares a little bit more. We start working as STAC to help distill that into a set of benchmark specifications, which help us capture things like the use cases and metrics and how we're going to go about testing these different strategic workloads. The process of the working group then is to work through that definition, that benchmark specification, get it to a point where we agree upon that. And then STAC will build a test harness, and technology providers as part of the organization will build their STAC packs, which then leads to testing that gets done as part of the process. Sometimes this is independently in terms of within individual firms. Sometimes it's an industry POC that we do together. And out of that comes reports, which provides information out to participants in the council. So as part of this process, those end user firms, it helps them reduce that discovery time and the cost of things that they're interested in looking at. It helps them drive better technology decisions, and it also helps them get better solutions from the actual vendors that they buy technology from. For those tech vendors who participate in this, it helps them with faster sales cycles. When they have a STAC benchmark report, it gives them that information that they need and things that these people, the participants in the council are looking for. Gives them better market insight and helps expand their market. So the STAC Benchmark Council has quite a few domains that they've worked on over the last 18 years. And so you can see what these categorizations are. We have the trade flow domain, which is everything you would consider in terms of fast execution and speed path that we have. So this is taking real-time data and driving information and decisions out of that. And then we have the analytics side, which is generally taking historical data, sometimes augmented by real-time data, but taking that data and doing computations, doing inferences on that, testing it, back testing it in order to get a decision out of that or information out of it. So these benchmark specs are developed in working groups, and again, they cover those key strategic workloads from the financial institutions. And they are categorized the way in which the user firms think about their architecture. So you can see through here, like trade execution and tick to trade, network IO. That's typically the way groups are, organized or architectures come together in terms of those organizations. So it helps them think about it. And the workloads that are designed and defined here vary in their intensity in terms of the levels of computation, the storage IO, the network IO, and all of those aspects of the operations that make up part of the benchmarks. So the benchmark specifications, the goal here is to develop standardized test definitions that you can use to measure the various strategic workloads. So again, they're driven by the council working groups. And the goal here is to provide an objective way of comparing tech stacks. You've seen people or you've seen tests before that look at just metrics on a specific layer of the test, like read performance, write performance, bytes in, bytes out. What these benchmarks do is they look at the performance of an entire system under test, which implements that workload. So you can think of, if we're doing something around enterprise time series and tick analytics, that involves everything as part of that stack, from servers to memory to CPUs to GPUs to storage, potentially network I/O are all part of the solution there. So the benchmark specs, in terms of what they define, allows you to benchmark any kind of technical solution that will satisfy the workload and the strategic workload, and to be able to compare those apples for apples, independent of what kind of technology they're built on. So the benchmark specs are defined to capture everything that's relevant to the tests. So in the specs, there's an overview, there's a part about the data and the data generation that's going to be used as part of the test. There's information about how we set up the tests, how we validate the tests and validate the stack packs that are built, what kind of operations are done as part of the tests, how they are going to be measured, and what metrics are going to be collected as part of this. And metrics are three different kinds. We got ones that look at the performance of the system. We have metrics that look at the quality in terms of if we're doing calculations, how do those calculations compare to the theoretical calculations? Or how does the quality of inferences square with a reference model? And then we also have efficiency metrics, which look at how the system performs in terms of resource utilization. So we could be looking at operations per watt. We could be looking at operations per rack unit. We could be looking at operations per cloud, dollar spent in cloud. And what these metrics do is they really refer this back to the business user who's looking at this. For anybody who is in a technical leadership role, they have to relate in terms of what they're doing back to their key stakeholders, and this will allow them to show or allow them to see how these systems perform on this basis. And then we have policies and definition and reporting standards for this. So each of the test metrics are versions to ensure compatibility. So every time you have like a V1 or a V2, you can compare the metrics collected against any other set that's tested the same version of that spec. Now, as part of the development of these benchmark specs, as I mentioned, we get everybody together to collaborate in terms of sharing information about what's important, what kind of thinking they would put into the process, things that they've thought about when they're architecturally building solutions. So vendors contribute as part of this process to help shape and refine those specs, but it's the end users that really set the requirements and the priorities for how these specs shape up and what gets defined. And overall, the specs are approved and owned by the end users as part of the council. And of course, certainly as part of this process, we've seen, vendors come and propose different aspects of metrics or test cases that we should do. And if they weren't important to the end users in terms of the way they were thinking, they didn't make it into the test specs. And the specs are available to all of the members of the council. Now, once we have the spec, as it takes shape, it gives us the ability to start building a test harness. And these are test harnesses that are built open source and available to the community. So we collaborate on many of these test harnesses with individuals, academics, with people at financial institutions, vendors help build these test harnesses. And for vendors that want to look at the test harness and produce those results, they can certainly take these test harnesses and use them internally. They have no obligation to disclose those results to anyone until they are completely happy. Now, end user firms, they take the test harnesses and use those internally to look at the performance of their systems. They can use these for benchmarking their tests or their systems over time, or they could be using them as part of tech evaluation to look at, maybe we do an A test and a B test where we only change one layer of that stack so we can gain insight in terms of how those layers, support the performance. The generated data from these tests is very, very thorough in terms of what it provides. It provides a lot of stats, and information in terms of performance, as well as detailed information in terms of how the testing occurred throughout the duration of the test. And we'll see some charts here in a moment. But what these tests really do is they help these engineering groups, especially from technology vendors who may be coming to FSI, to financial services, really understand what the use cases and the requirements are there. And what we've seen over time is that as technology providers have come in and used these benchmarks and really started to tune and test their systems, it's really led through an iterative process. Sometimes products have had to go back to engineering to have enhancements in terms of what they're doing in order to get that before they really feel comfortable going out and putting it in front of end users. Now, for each of the test harnesses, the test harness, as I mentioned, it is defined in such a way that it can test any solution stack that occurs that's being used for the strategic workload. For each test harness, a stack pack gets developed that adapts that test harness to the tech stacks. So for instance, like in STAC M3, which is our enterprise tech analytics testing, stack pack is built, which generates data for the test, loads that data into the database, implements all of the operations on that database that are compliant with the benchmark specs, collects the data that comes out and provides that data into the test harness analysis. And that's what comprises a stack pack there. And so building these stack packs for a vendor helps them test in order to generate results for the end users who are interested in them. But it also gives them an avenue to work with technology partners throughout the industry and help see, how they can partner together and build and complete solutions that will be interesting to various parties in the group. So it's been a great avenue for that as well. Now, when you use the test harnesses, the results may not be disclosed except by a stack. I'll talk a little bit about that in a moment. From the test harness, you get quite a bit of data that comes out, and there's data analysis tools that come from this that allow us to do various things in terms of giving you tabular summaries of your data, giving histograms. You can see the one in the top middle of the chart. This was a 24-hour test with a cloud networking test, which shows how that network in a cloud service provider between AZs actually performed over that time. And we see congestion that occurred at the early part of this test and then cleared up over the course of 24 hours. Some of the other charts and the very colorful charts come from our STAC AI tools, which is where we're testing inferencing solutions and their performance. But these kinds of things will allow whoever the engineers are that are using the test harness to actually look at the performance, understand the performance, help them see when latencies are occurring. A lot of times when you get summarized performance information, you don't see that or understand where it's happening. This allows you to see it in terms of whether it's periodic or whether it's whether it's an outlier, but it gives people a lot of information that can help them. And for the stack packs, we have quite a selection of people that have worked with us and built stack packs in the past. So this is kind of a list off of our website in terms of all those that are available. Quite a few available in terms of the trade flow fast workloads, various different networking technologies or data distribution, and different analytics workloads that have been done in terms of back testing, STAC M3, tick analytics, or the risk computation side. Now, as I mentioned, once you take the test harnesses, those results can be used internally and can be discussed with your groups. And if you have a couple partners working together on those tests, you can certainly discuss those results. But you cannot disclose them outside of your company when you set this up. So looking at the entire process here, the first part is setting up your system under test in order to do some initial testing and preparation for a potential audit. So you set up the system, what we call a system under test or SAT, and your test harness. If you need to, if your technology solution or stack is new and can't use one of the existing stack packs, you may need to develop that yourself and then validate that with STAC in order to ensure that it provides all and does all of the benchmark operations correctly. And then it's a process of tuning, testing, tuning, wash, rinse, repeat type things throughout your process until you get to the point where you're happy with those results. And along the way, STAC's, willing to, we constantly work with people in terms of discussing their results and talking about, what we see, what they see. And in terms of once you have those results, they are governed by the STAC Benchmark Council. As I said, you can't disclose those. But there are different ways of disclosing. So your options are to do that through what we call the STAC Vault or through a STAC audit. Now, for publishing through the STAC Vault, the goal here is this is at no cost to vendors. So they can take the test harness, they generate the results, they do the analysis, they build the testing report and provide that back to STAC. What we do then is we review the report to ensure that it's complete. We look at the analysis, we look at the tables, we look at the sections of the report to ensure that everything's complete. But what we don't do is we don't validate those results. We don't validate the testing, the performance configurations that are on the system. We don't validate the actual components of the system or the analysis or any parts of that report. We're just ensuring that it's complete. And so once we have that, and once you decide to disclose those to the vault, we'll publish that report on our site to our subscribers. And it's clearly marked that it's a STAC Vault report and not audited by us. And those results are considered under NDA. So they may be provided to members of the Benchmark Council that have subscriptions or have access to the STAC Vault. But the limitation is that they can't be used as part of marketing materials or disclosed outside except through the STAC Vault. So you can always point customers to it, or point parties to it that may be interested in it. But again, then once they, get access to it, they're under NDA through STAC. And when we get to our events, STAC will, of course, mention that the Vault report's available, but we won't go into details about those results. Now, the one that most vendors choose to do, and this is because they would like to talk about the results in terms of their marketing materials, is that they ask us to perform an audit of their system. So what they do is they come to us, they contract for that independent testing and an audit of the system. They get their entire system prepared, set up, tuned, and once they're happy with the results, then they will provide that system over to us for testing. They'll provide us a set of results that we look at and we'll use to go into the audit. And then they turn over the set to us and it's hands off. At that point, we do an analysis of the set and a pre-run on the results. We'll look at those, and once they're okay, and once everyone agrees that those results look okay and confirm with what they were expecting, we will run the full tests and do the analysis and generate a STAC report from that. As part of that reporting process, we get input from those parties that are participating in the audit. Sometimes it is one firm that's doing it themselves. Sometimes it's a setup of partners, like for instance, a server vendor, an operating system vendor, a NIC vendor, all working together to test and tune this set. So we get their input in terms of things like their product information and participants and commentary on those test results. And then we finalize that report and able to publish that report on our website. And the good thing about the STAC audit is those results then may be used in terms of marketing. So we provide overall results in terms of records and comparisons to other sets that they can use in terms of their disclosures. And they can also hand out that report to their prospects and customers and give them access to the full information. They don't have to go to the STAC website. That is the full report. There's also a secondary report called the configuration disclosure that gets produced, as well as some of the deeper data that gets done as part of the audit. And both that config disclosure and the deeper data is posted with the report, but is only available to members who have a subscription or access to the STAC Vault. Now, STAC reports are, I'd say, widely respected in the industry. People know that as we go through this process with the STAC audit, we're independent in terms of our working as part of this process, and in terms of independent from every partner and party as part of this council. When we go through an audit, we're very, very rigorous in terms of our inspection of that, our testing of that, and holding the highest standards to the testing and the process. So people respect the STAC reports that come out. They know that there's been a lot of important due diligence that's gone into this. And it's something that a lot of vendors have told us this is an important piece of collateral for them that they can hand out, and it's something that they use over and over again. And it's also something that has really short-circuited those cycles of getting into the end users. So it helps them establish that value prop and get onto their short list for technology evaluations. Now, if someone had a technology that they wanted testing or tested that, say, we don't have a benchmark suite, we don't have a domain for it yet, there is the possibility that we could work together to find a custom report and a testing process for that. And once we do, we socialize that with one or two end user firms to validate the process, and then we'll do custom testing and a report as well in terms of that. And you can see some of those on our website. Like we did one with Raft, I think it was about 1.5 years ago, for testing their RF networking. So you'll see all of these are listed on the website. For a STAC report, anybody with a login in our website can have access to the full STAC reports. And then anybody with an ID and a subscription can have access to the config disclosures and the deeper data that's posted alongside them. So I thought I'd go through a STAC benchmark example. And this is one that we published last year. It's STAC T1, which is our tick to trade benchmark. So for STAC T1 E-mini, this is a specification that really measures the tick to trade latency of trading solutions that consume recorded market data from the Chicago Mercantile Exchange for its CME E-mini futures, and then looks at that data and decides when to trade and sends orders to the simulated exchange using Fix 4.2. So you have UDP data coming in with the market data, you have TCP going out in terms of the trades, and this is a high precision benchmark. So we use wire timestamps, we use data capture and timestamping as part of this, so that way we can get nanoseconds in terms of those timestamps. But this can work for any trading platform, whether it be software or hardware. The test itself includes that protocol handling. So the market data comes in, the system has to get the packet, has to understand it, parse it, and be able to determine through its trading logic if it should generate an order. And there's an algorithm as part of the benchmark specification that says when you actually generate a trade. So we tested a product from a company called Ad Hoc Technology. So they have built an FPGA-based ultra-low latency platform using the AMD Versal Premium platform. So their system under test was their 1U appliance, which had two 50-watt power supplies. They used the AMD Xilinx Versal Premium with 4 GB of memory. Their entire code for the test was written in VHDL. It ran on the FPGA side of that platform, and the ARM processing side of that platform was not utilized at all. But in their product, you could install some code on there to actually do some other processing. But for this test, it wasn't utilized. We also needed to, because the sort of precision around this, we have to have a latency monitor that is capturing the data, doing that. So we used theirs. It was part of the test setup that we did. But also because we were using theirs, we wanted to validate through a secondary method and essentially not allowing them to grade their own homework, we used a solar flare card to actually perform a secondary validation to look at the measurements. So the test setup itself is like this. We had a system which is our test controlling box on the left. It produces the data. We have a series of connections set up with splitters, which is taking the data both into the set box as well as the data capture box at the same time. That allows us to timestamp and look at those solutions. What we also did was we took that set box out of there and put a fiber cable, crossover cable or breakout cable there in its place, and then did the same benchmark test. And that will allow us to essentially subtract out the cost of the networking and get the actual latency of the set in its place. And then that secondary validation we did with the solar flare card on only one side of the feed because of the ports on the solar flare card. But we got our results, and this is the way that we look at these results in terms of mean, standard deviations, and various aspects of those. In this test, we run those rates at 1 times market rate as well as 8 times market rate. And there's actually a lot of results that were put in terms of the report. This is just a couple of them. We can also see some of the charts that were in the report and things that we present at our events, which I'll talk about in just a little bit in the future. But we can see in terms of how this set performed at both 1x and 8x in terms of the various stats and metrics that we collect. So you can see things like its standard deviation, its mean, median, and various percentiles as part of the collection that we gathered. Now, they also, as part of this test, they looked at everything that we built in terms of the benchmark. They proposed another metric, which we did as part of the test. So it was kind of a custom part of the test. We published this benchmark, which said, okay, once the proposed metric once the algo has figured out that it needs to trade, how long does it take once it has all that information to act? So it's essentially looking at the time for the trigger. And so you can see the performance of this set in terms of its summary stats, very flat in terms of its curve, as well as all the data captured in terms of the mean latencies that occurred over the test duration. And we measured each of the packets or each of the orders that went through as part of that test at 1x. Now, as I mentioned, those are things that we presented at our events. We also, as part of the STAC Council, we host STAC summits. And this is a place where people come together to talk about the different technology workloads and things. So we build the agendas for our STAC summits based on the workloads that things that people are interested in as part of their capital markets trading operations. Those topics cover things that are really innovative solutions and technologies that are out there in the market. We do those agendas together with both end users and vendors in terms of coming up with what we're talking about. So the things are very timely, very topical in terms of what's on the top of people's minds. And we also present those benchmark and research results that we do leading up to the summits, so people get the latest information that's there. One thing that's very different about our conferences here, they're very deeply technical in terms of the topics and the panels and things that we talk about. But it's also the operation. People love coming, they love hearing the sort of the tech topics, but they also come to really network with other people within the industry. We do get really great attendees that come to these, a lot of C-levels, a lot of heads of technology and architecture and technology development, as well as operations. So they come, they get to meet and socialize and compare notes. We do these in New York, in Chicago, London, and Singapore, and this year we are planning even more. We're planning one more in Asia and hopefully one in Australia as well. So also last year, we had a separate event covering artificial intelligence. And what we decided this year was to bring that event back into the STAC Summit. So that way it gave everyone one event, one day area where they can meet and talk together, reach the highest number of people, and include that as an AI track within the STAC Summits. And STAC Summits are open to members of the council and sponsors of the event. So if you're interested or you want to know more about that, just don't hesitate to reach out to me. And these are our events that are coming up in the spring. We're doing Singapore first on April the 8th, London on April 29th. And in London, we have the core track, which covers analytics, big data, fast analytics, as well as the AI track. Same thing in New York on May 13th, and then May 21st in Chicago. So that is the end of the presentation. Thank you. I'm interested if there are any questions.
Wonderful. Yeah, let's open the floor for questions.
So I have a question. Do you
Yeah.
mostly do electrical benchmarking, or do you do optical, or a combination of all of them?
You know, it's very much up to whoever wants to build and test their SUD. So, you know, like we've done different tests, you know, in terms of the networking, we've done different tests with copper and optical. We've done all kinds of different switch solutions that are in there, different layers. You know, it really comes down to what kind of technology that you want to apply to these strategic workloads and what you want to show.
And do you do like up to 100 gig, 200 gig, or is it mainly, limited to 25 gig and below?
You know, so far it's been 25 gig and below, and that's because that's what's been predominant in the financial industry in terms of especially what the exchanges have been providing.
Thank you.
Sure.
Hey, Jack, great presentation. I had
Thank you.
one question, which is, so if I'm somebody that has a SUT, a system under test, and I want to test it with a STAC test harness, if I'm understanding right, I kind of have two options. It sounds like one is I can kind of go to STAC and have STAC do an audit and have STAC test it, or I can purchase the equipment in the test harness, whatever that might be, and test it myself. Am I understanding that right? That those are kind of the options?
That is correct. That's
Okay.
correct. And you know, with the Stack Vault option, it's you know, you become a member of the council. You get access to test harnesses as part of that membership. So you know, you have everything you need. It's then just up to you to set it up and do the testing and tuning. And it doesn't cost you anything then to publish a vault report.
Okay.
But if you want Stack to do the work and Stack to, you know, run the test, generate, do the analysis, all of that, it's a paid project. We don't look to make a whole lot of money on those. It's more important for us to get that data and research out there to participants in the industry. So we kind
Gotcha.
of cover our time with it, but it's something, you know, of course, we have to dedicate resources to.
Oh, that makes sense. I guess another question I had was it's interesting that you have regulators as members.
Yeah.
How does their participation typically work? Like, do they? I mean, I would imagine most people, like you said, are interested in business results. You know, do the regulators look at STAC in terms of, you know, like if we, the regulator, audit somebody, we're going to ask for STAC results? Is that why they're there, or what is their motivation?
You know, it's interesting because they have come to the summits quite a bit just to understand technologies and latest things that are coming. So you can imagine, like in the AI space, this is a very new tech set for everyone, and I think they're trying to, you know, a lot of them want to come and find out what the latest greatest is that's going on in the industry.
That
Uh,
makes sense. Yeah.
I mean, they don't participate in tests themselves. I know that they get the reports and look at them.
Right. But yeah, they're not like mandating them or anything like
No.
that, which I wouldn't expect them to. But no, great. No, that's informative. Thanks.
Yeah.
Right.
Jack,
Any more questions?
this is Hank Carl.
Hi, Hank.
Hey, I'm looking at the STAC research domains. You've been speaking of STAC as mostly for capital markets, and you know, admittedly, that's where the money is and where people want to sell into. The other thing is the capital markets have the money to do this kind of research and do it well. You've got two domains, research domains, AI and machine learning, and the
Mhm.
other is public and private cloud, and maybe some of the others too, that are not limited to financial. They're
Yeah.
everybody. Are you reaching out to those areas too, or is this a general? Are these reports going to be general enough that people in I don't know, people in Meta could use it as a tool?
So it's a really great question, Hank. And a lot of the sort of benchmarks that have been built up have been focused on capital markets use cases, because of course that's who we've worked with. But we do recognize with a lot of these things, exactly the ones you mentioned, artificial intelligence, machine learning, cloud. There's others that we've thought about and looked at before too, in terms of things like blockchain that go outside of just capital markets. There's a lot of other use cases for these, a lot of other industries that are interested. And that's an area where we're looking at growing this year. The first area that we're looking at growing is into health, bio, and life sciences. And we STAC as part of our, we were acquired last year by N Squared Group, which essentially what they're doing is building a portfolio of companies who are scientifically have scientific businesses, and have different industries that they satisfy, have sort of that scientific culture. So we're one of them. They've also have other other portfolio companies in bio life sciences, as well as energy and oil and agriculture. And so it's something where we see this is where we want to partner with those firms to actually take the sort of model that we built around the council and around building benchmark specifications and being able to use those in different industries as well.
Okay. And I see there's a I won't say synergy, but an orthogonality that OCP TAP, this group, doesn't do this kind of benchmarking that you're doing. They're both going towards the time sink area, but
Mhm.
there's there should be a way to leverage off what each other is doing. Are there any plans for that?
Not yet, but we'd love to.
We are open.
We'd love to collaborate.
We are open to
Let me
more end.
let me give you an example, Ahmad. Meta, I don't know if everybody's heard this, but Meta published failures they found in Llama 3 pre-training on a 16K GPU system.
Yeah.
The report covers 53 days. Basically, they found they had one interruption of training every 3 hours that they had to restart.
Mhm.
On average, every 3 hours, 80% of them were hardware issues. TimeSync would help that with because of checkpointing, with the more accurate TimeSync, better checkpointing work. So that's why I think there's some commonality here and some very reaching out to other industries that are doing AI and cloud, of course, is important.
Yeah, indeed. So, I mean, we have Bijan here as well. Jack Bijan is the CTO of OCP,
Hi.
and I mean, he was busy with another call, but just like I mean, the good thing is like the presentation is recorded. You can go through it like later, Bijan.
I will.
And but overall, like what Hank brought up. Hank, do you want to bring it up again because Bijan just joined?
Sure. This is a report from Meta on a Llama sorry, Llama 3 or Llama 3 pre-training on a 16K GPU system, covering a 53-day period, and they found 419 unexpected interruptions, averaged one every 3 hours, which means you had to restart training, which is where checkpointing is very important. So that's with better time sync, you can in some cases have better, faster, more efficient checkpointing. And I don't know what you guys are paying for a 16K GPU system, but I've heard a 10 GPU system is like $1,000 an hour.
Yeah, I'm sure Ahmad may have mentioned it, but Meta wrote a paper on the training efficiency that we actually take a look at quite often. We have an effort called RAS, which is reliability, availability, and serviceability. And this RAS effort is to kind of solve for that, right? Solve for all the training stoppages and these things. And so the focus areas so far have not included timing, which I think is a fantastic suggestion, and we should all of the focuses so far have been on unexpected memory errors and errors in networking and more known knowns, but kind of building a framework to kind of track it all in terms of training disruption and also cleaning up all of the there's a lot of intermittent or declared errors, and so they're trying to find the sources of all of them, find ways to identify an error when it happens. But anyway, totally agree with you. Yeah, I think that's a fantastic idea, and maybe something that we can take on here too, like in this TAP group would maybe like a work stream would be to say how to have like a synchronization RAS effort where we work with the guys like the hardware management project and define this here, and then you will define like when's it a problem, how's it a problem, what are the remediation type things, and then the hardware management guys can do all this telemetry and all these things to make it real.
Bijan, I think that would work great in partnership with STAC, because STAC does testing, they develop tests, so they're doing the testing part of this. The implementation part you're talking about would certainly rely on tests.
Yeah.
Yes, that's the the errors that we don't see are the killers, right? So the silent errors.
And Jack, I said financial was where the money is, but I don't know, at $10,000 at $1,000 an hour for 10 GPUs, when you multiply that by 16K, you're talking real, by 53 days, you're talking real money.
Yeah.
Even for Washington.
Yeah, I mean, if you look again, the Meta paper, I mean, it gives you, if you just use napkin math, I won't use any specific math, but I'll use napkin math and say that their training efficiency was less than 50%. So let's say you take 50% of the operating costs per time. That is a big number when you consider a petaflop or exascale, AI cluster. So that's big money. That's not small money. So if you spent 300 million training, that's 100 million of waste. That's not good.
Jack, do you want to add something to it, like with respect to like what do you expect, let's say, or like how would you see OCP TAP, let's say, or OCP at large collaborating with STAC?
Yeah, I think it's one where we find the right places to collaborate in terms of what's important workloads. Over time there's been things that around MIFID where time synchronization was very important, and we actually worked together with a lot of different parties to build a STAC TS benchmark. So it's around time synchronization, data capture, accuracy, and things like that. But I think, there are problems that come up like this in the industries, which is where it would make sense to, have different parties collaborating as part of this process and participating.
All right. Let's see. Anyone else wants to add something? Paul, do you want to add something?
Sorry, I couldn't find the mute button. So you know that I'm not, I don't subscribe to the idea that you can synchronize time.
Sure.
I spent 4 episodes last year trying to explain that. I do know that it's really, really hard to get out of the belief system that synchronized time works that way. But I do think that the point that's just been raised is a really important one. How are you going to try and make these checkpoints a lot more efficient? And it turns out to be really similar to the problem we have in backups and restore and archiving, 20 years ago in the SNIA. It all comes down to whether the timestamps are accurate or not. And so pushing on that button to try and make them more accurate actually is barking up the wrong tree. And so I think this is definitely an area that's worth investigating. We are hoping to actually deal with this problem directly in the Ethernet 2025 effort, which, by the way, is happening at the same time next Wednesday and every other Wednesday to interleave with the OCP TAP. But it's definitely a really interesting issue. It goes into the physics, and once you can see it from the right angle, it seems so obvious that of course the world isn't flat. And it is literally that level of like, how do we get, and we're seeing it now from lots of different directions, from physicists, from computer scientists, from networking engineers. Everyone is seeing this, the idea that time is a single linear line along which you can order events. And on January the 1st, I gave a talk that basically said, timestamps are an illusion. They can't be fixed in software. And that was kind of the conclusion I came to, which I hope everyone will go back and look at. But the point that's been made here is a very good one. The idea that if we can do some kind of synchronization which doesn't assume that timestamps are a good ordering construct, but actually assumes that they have to be manipulated in the protocol some other way, I think that's a really good path to go down and see if there's some gold at the end of that rainbow, because these are real, honest to goodness, practical issues that real data centers have every day.
Yeah. All right. Anyone else? Hearing none, we can give back perhaps 5 minutes and
Hey,
Jack.
one thing.
Yes, go ahead.
I just thought of one thing. So maybe we can have an offline async discussion about how to follow through on Hank's request to kind of pursue this, to kind of work on these things together. So
Yeah, maybe you and Jack can have a one-on-one, see what you guys can figure out.
Sounds good.
yeah. All right. Sorry about that.
Right. And then I'll get the slides from Jack, and we'll put them on the wiki so people can see the current slides.
Great.
And if no more questions, then we can give back a.
I have one comment, Ahmed.
Great, Hisham, go for it.
Yeah, the next Wednesday meeting will be on February 12th. But it will be at 10 o'clock, not 11 o'clock.
All right, yes, that's a good reminder. Yeah, so there will be just an exception. The next call will be at 10 instead of 11. Yes.
You can announce it, Ahmed, the way you do it all the time.
Yeah. We will have the thing changed, basically. And then the speaker is Kamal. Can you say the speaker?
I forgot the name. Yeah, Kamal something.
No problem.
I can say, yeah, no problem.
Yes. All right. So we'll see everyone in 2 weeks.
All right. Thanks, everyone.
Thanks, everyone.
Thanks,
Thank
Jack.
you.
Bye, everyone.
Bye-bye.
Bye.